Hi, in this video I want to show you this vending machine. It is the Ecofill. Ecofill is a cleaning products vending machine. It can dispense any liquid product with a peristaltic pump. I have here, like this one. And it is based on this main board. Okay, I am using the ESP8266 to make this one. I made the PCB and you can program it on Arduino. I have the source code right here, can be done in Arduino. But the interesting part about this is that the board has a connector to allow expansion modules. For example, right over here we have an RTC plus a memory to know the time and store data. If we continue following the cable, we have a small LCD module. It has a Chemet proximity sensor plugged to it. Here is it, the proximity sensor, right over here. And the function of the sensor in this particular setup is to control the lamp of the dispenser right there, this one, and the LCD brightness. So for example, when no one is in front of the machine for 30 seconds or more, the lights turn off and allow us to save energy. If we continue, we can find a power meter module. This is used to estimate the power consumed by your machine. Over here, we have for Chemet CT007 current transformer. This is the mains power. And we also have a voltage transformer to read the AC voltage on the line and do more precise calculations about estimating power. Okay, we are our mains inlet. This is a inline filter. It's nothing to talk about. It's just for a fancy connection. And we have the power supply over there. We have our mains power and 12 volts. Okay, right here are 12 volts DC. But if we continue to see the periphericals, you can notice this relay board. This is an slot expansion module. It manages our product selection with these buttons over here, or cancel button right here. And we also have a pressure sensor. The pressure sensor is used to estimate the product in the tanks. Right now I only have one connected, and I have connected this to all the products. As you can see, is the gray wire over here is connected to all products. It has an analog input, so we can estimate how many of the product we have in the tanks. And right now we only have one peristaltic pump. They are expensive, so I only have one at this moment, and it's connected to our product number 4 with 12 volts. And you can see these are the tubes. For the peristaltic pump is the larger one, and the smaller one is for the pressure sensor, okay, or level sensor. Right here I have some water to test. And over here we also have this cable. This cable is a USB to serial converter. So we in the computer, for example, if we open the Arduino terminal, we can see our machine status. Okay. So for example, right here, we are watching the balance in the machine. We have 0 Mexican pesos, it's unlocked. We have the date and time, and we have the voltage, the current, and the power estimate using by your machine with this model. Okay, I am using the Chemet CT07 as a current transformer to read the AC current safely. Okay, right now we are consuming approximately 7 watts. Is totally okay. And as you can see, we also have the slot expansion module reporting data. Our tube is outside of the water, so we have 0 stock. If we press the buttons, we will have a out of stock notice, and the machine will block the purchase of the products. Okay, I am going to put this in the water right here, and you can notice how the stock quantities have increased. Okay, right now I only using this as a demonstration. I don't have the capacity tanks in my desk, but you basically define the ADCU levels, a minimum level and a maximum level, and the capacity of your tank, and it calculates how many of the product you have based on that. Okay, it can vary product to product because of the density of the products. And if we select products right here, we now see is unlocked to do the sale. Okay, I am going to purchase this one, hand sanitizer. The machine is telling us that this product is 5 Mexican pesos. I am going to put that in the coin acceptor. Let me move to, you can see better. Okay, right there. And the money, when the money is in, the machine automatically do the sales. Okay, this is an IoT project. This is connected to our Wi-Fi network. We have a control panel right here. We go to our browser. This is our control panel. We are going to log in, and we can see the sales. Okay, right here is the one we have made a few moments ago. Okay, also we can configure the LCD message. It's the same that you are seeing here. It's easy to save the planet. And right here we have the same one. And also we can set here our products. This is our product ID. This is the cost of the product. This is the time the peristaltic pump will work for dispensing the quantity. For example, we have here 50 milliliters. This is the quantities. You can see 50. Okay, so no problem over there. And this one, the counter column, is used when we have another kind of pump and we are using a flow sensor. Okay, so we can place a flow sensor like this one and count the pulse to do the precise dispensing. Okay, we also can see here in the web control panel that we also have the power meter module installed and the data logger. Okay, so if we are going to the events tab, let me repeat that, events, we can see all the events and error message from our machine. Okay, so it's a complete solution. We also have the first day of the month. We generate a summary with last month sales. Okay, sales, the income, and also the power consumption. Okay, the total power consumption during the last month over there. Okay, it's an easy to do. The machine is also enabled to use Google geolocation API right here. Okay, so if we have this key with the Google geolocation API, the ESP scans the nearest Wi-Fi networks and Google tell us where our machine is it. For example, here in location, we can see where our machine is. Okay, no problem over there. It's perfectly working fine. And another important thing to consider here is that this control panel can change based of what modules we have plugged to the IoT controller. Okay, so right now I am going to reset this. Okay, and I am going to disconnect the wire, so no other referral is there. It's disconnected, completely disconnected. Okay, right here, and we start it again. We're going to our Arduino terminal. Oh, we are not going to see anything because the terminal is the same way. Okay, so in a moment I am going to show you the boot process. Boot right here with all modules unplugged. We log in again, and as you have noticed, the interface has changed. Okay, this is the single mode interface. We can configure cost, we can configure time, and the only thing we need to do is to enter money. We try. Ahí está. Okay. Right there. And here in sales, you can see it as the 0 slot sale. Okay, here is it. Now we are going to try with our peripherals. We plug the cable again. Okay, it's working. Now I am going to reset it, but let me show you the Arduino console. Okay, it's reset, it's booting up. So here in the booting process, okay, you can see how it detected the power meter. Here is it. The LCD module is right here. Okay, our data logger module. The slot expansion product for allowing us to sell more products with their respective data. This data is stored on EEPROM memory, so we don't necessarily need internet to do the sale. Okay, we continue right here. It's connecting to the Wi-Fi network over here, and right now after that the machine send the logs to our IoT cloud right here, or location. It resets configuration. Okay, the products on the slot expansion model are right here, and it thinks the date and time. And now we can see our products right now, like this. Okay, it's an easy to configure. And for example, the Kemet proximity sensor, when I don't move in 30 seconds, is going to turn off the lights. So I am going to stand over there. Okay, the energy, the power monitor allows us to estimate the power. So when we turn off the lights, it allows us to save energy, and we can measure how many energy we save. Okay. All the expansion models or the slaves are an I square C, works over I square C, and they are just slaves. So the main processor doing the task is this one. This one decides how to do and when, and the other modules are just there to support our IoT controller to do that. Okay, the lamp has turned off, so I am going to step in. And you notice how the light turned on and the LCD brightness is now not complete full at full power. Yeah. So it works as expected. Okay, so I am going to make the purchase for our peristaltic pump. We only have one because they are expensive. We are going to try to buy that. This is the product number 4. Okay, product number 4. We place an empty folder. Okay, it's right there. And now we need to enter the money. This one costs 10 Mexican pesos. Okay. The water is flowing through the tube into the peristaltic pump. Okay, it's starting to flow, as you can see. Okay, and in the LCD we can see the serving process right there. And for example, this bottle is too small, so we are going to press cancel to stop the dispensing right now. Okay, the product log was saved to the internet into our server right there. If you notice, it has the full interface with all our data, and you can see here this product sale. So it is an interesting project. It's pretty complex. I have designed the web platform. I have designed the software and firmware in the machine. I have designed all PCBs, and also I have made the Arduino program to run it. So it's a powerful solution for a vending machine design. It's modular, so it allows us to change what our machine does anytime. And one of the most impressive things in using the ESP8266 is that it allows over-the-air updates. So for example, we can make new firmware and it will be available instantaneously for updates. So we can keep this controller updated anytime, and we can keep adding new module functionality. Okay. This is my project, and I hope you have enjoyed. Sorry for my bad English. If you have any question, please feel free to contact me. Thank you.